At the time of the first Arid Recovery and closure was being proposed, the stick nest rat recovery project, which I'd been working on with National Parks and Wildlife since 1985, was looking for a suitable site to re-establish the rats on the mainland. There used to be two species, the greater and the lesser. Both became extinct on the mainland, as far as we know, in the 1930s. Fortunately, the greater stick nest rat survived on two small islands, the Franklin Islands, south of Ceduna. The recovery plan for the stick nest rat, written at about that time, had the aims of establishing at least 4 additional populations of the rats. Wanted to have at least 500 mature individuals in each population, and we wanted as wide a geographic range for any new populations we set up. And that map there shows that Arid Recovery, which you saw before, is within the former range of the rats on the mainland. When Arid Recovery was being planned, there was quite a lot of new information about the rats from several sources. There'd been a recent population study on the Franklin Islands, a captive breeding program for them at Monarto. There'd been 3 additional island populations established from captive animals bred at Monarto, at Salutation Island in Western Australia and Reesby and St Peter Islands in South Australia. And we'd also learnt from 2 failed attempts to reintroduce the stick nest rats to mainland sites at Yucumurra Sanctuary and Venus Bay Peninsula. So in 1998, Arid Recovery undertook a trial release of just 8 stick nest rats into a small area within the first major paddock, called the Main. And they did well. They put on weight and they started building stick nests. So in 1999, got 91 more rats from the really strongly growing population we'd established at Reevesby Island in Spencer Gulf. And then in 2001 and 2003, a further 36 stick nest rats were released into the additional paddocks that were being built at Arid Recovery as it was growing. So, did we have an early success? Initially the rats thrived, they ate the food plants that we expected they would, and the population increased with successful litters of young. They even built really quite substantial stick nests, for which they're named. But unfortunately, after more than a decade, the stick nest rat population started a steady decline to eventual extinction. This was caused by interactions with other reintroduced species that came after the rats and the effects of a severe and prolonged drought in 2018-19. This graph of rat track monitoring transects indices between 2000 and 2020 shows the different colours show different paddocks within the reserve. The grey bars show the drought periods, and you can see there that the population increased to about 2012 and then gradually declined, or fairly rapidly declined, to functional extinction before the drought even started in 2018-19. So basically the decline and extinction of the rats was linked to droughts, to competition, especially with the burrowing bettongs that had been reintroduced soon after the rats, and also due to predation by native predators that included the local sand goannas, quolls that had been reintroduced quite late in the piece, and also owls. As the burrowing bettong population increased steadily, the stick nest rat population declined, and you can see here the top graph is for the bettongs, and the axis here is in the hundreds of tracks per kilometre. For the rats, the equivalent scale is just in the tens of tracks per kilometre. You can see that after the 2008 drought, soon after, about 2012, the stick nest rats started to decline fairly rapidly, and if you consider how rapidly that booming bettong population was going, you get the inverse relationship. So the releases of and I wanted to say that vulnerability of the rats to predation increased as the food resources and the vegetative cover dwindled during droughts and as the bettong population boomed and impacted on many of the perennial plant species. The releases of the western quolls into the Arid Recovery Reserve in 2015 through to 2018 was a calculated risk as far as stick nest rats were concerned. Unfortunately, their releases coincided with the rapid declines of the rats due to competition from the booming bettong population, and even more unfortunately, this was at a time leading into the reserve's worst drought and led to their ultimate extinction. So the important conclusions that can be transferable from this arid recovery experiment with stick nest rats and with other later introductions is that firstly, safe haven practitioners shouldn't assume that reintroduced species will pass through predictable population fluctuations or that viability is assured even after a certain period. Secondly, intensive monitoring to assess population viability may actually require decades, particularly where multiple species are reintroduced, where release sites are confined, in this case by fences, and where the climate is unpredictable. So we also need to learn from the arid recovery and other reintroduction experiments if we're going to try and find a place to put rats in the future. Habitat essentials for stick nest rats must be met through planning for severe drought and heat conditions and carefully assessing likely interactions between the mix of local and any reintroduced species. Offshore islands with more mesic predictable environments still seem the best option if another stick nest rat population is proposed. However, if a mainland safe haven is considered, it may need to be in a more mesic area outside of the species known former semi-arid and arid range.